Understanding haptic feedback technology. Haptic feedback is a technology that simulates touch sensations through vibrations, pressure, or motion. It enhances user interactions by providing tactile responses, making digital experiences feel more realistic. Common in gaming, virtual reality, VR, and mobile devices, haptic feedback bridges the gap between digital content and physical sensations, improving engagement and immersion. How haptic feedback works. Haptic feedback operates using actuators, small motors that generate vibrations or movement in response to user input. These actuators mimic real-world sensations, such as the recoil of a gun in a video game or the feel of different textures on a touchscreen. By varying intensity and frequency, developers create lifelike touch experiences. Haptic feedback in gaming. Modern gaming controllers like the PlayStation 5's DualSense use advanced haptic feedback to create realistic sensations. Players can feel tension in a bowstring, the roughness of terrain, or the impact of an explosion. This level of detail enhances immersion, making games more engaging and emotionally compelling. Enhancing virtual reality experiences. In VR, haptic feedback improves realism by simulating touch-based interactions. Gloves and suits with built-in actuators allow users to feel objects, textures, and forces in a virtual environment. This technology deepens immersion, making digital worlds feel more tangible and interactive. Use in smartphones and wearable devices. Smartphones use haptic feedback for notifications, typing, and user interactions. Apple's Haptic engine, for example, delivers precise vibrations to simulate button presses or provide subtle cues. Wearable devices, such as smartwatches, use haptics to alert users without sound, ensuring discreet communication. Impact on medical and training simulations. Haptic technology is transforming medical training by simulating surgical procedures. Surgeons can practice complex techniques using haptic-enabled tools, improving accuracy and confidence. Similarly, flight and military training simulations use haptic feedback to create realistic environments, enhancing learning and skill development. Automotive industry applications. Car manufacturers integrate haptic feedback into touchscreens and steering wheels for safer, more intuitive controls. Vibrations alert drivers to lane departures or upcoming obstacles, reducing reliance on visual cues. This enhances driver awareness and improves overall vehicle safety. Challenges in haptic technology development. Despite its benefits, haptic feedback has challenges, including high development costs and hardware limitations. Creating precise and varied sensations requires advanced actuators and software integration. Additionally, achieving consistent haptic effects across different devices remains a technical hurdle. The future of haptic feedback. As technology advances, haptic feedback will become more refined and widespread. AI-driven haptics, improved actuators, and expanded use in industries like healthcare and gaming will enhance digital interactions. With continued innovation, haptic technology will further bridge the gap between virtual and physical experiences.